Excellent. Fantastic. I presume this is working. Very well. I am really excited to be here. I never really thought I'd pull the trigger on doing a talk here at SGF Dev, but Levi and Jennifer kind of coaxed me into it, and with a few conversations, I ended up here. Thanks for doing that. This is going off the rails. How do you solve problems where no one has gone before? These are some stories from me learning how to solve problems the strange way, mainly by coercing a 20-year-old game engine into being my model railroad. I spent a lot of time where no one has written documentation or done any libraries or really written anything down, so your ability to solve problems on your own is just an essential skill in those arenas, and it taught me so many lessons that I brought back to other areas of my work and life, and just stories and things that I can share. My name is Isaiah Groves. I live around here in Springfield, and I'm just a little bit of everything. I love collecting information, I love machines, and I love railroads, and I am the president of a nonprofit association that is dedicated to teaching people hands-on history through model trains, the Ozarks Model Railroad Association. I'm not a tech worker in my day job. I drive a cement mixer and very much enjoy it, and I do things like rebuilding that parking lot out there. That's something I've been working on last week. All the same, every spare extra second of my time I spend in the digital arena solving problems and learning from things. By night, I am an autodidactic generalist, which is absurd fancy talk for I like to learn about anything and everything. I taught myself Python, 3D modeling, environment design, a few other things. I 3D model industrial equipment, mostly railroad equipment, but occasionally some other things. I do it mostly as a hobby. I've taken a few jobs on commission. That gondola there is one of them. Most of all, I like learning new systems. I'm very okay with being in over my head, and I get thrown all kinds of novel problems all the time. I write scripts that people use in communities. I just solve problems, and I very much love it. It's really shaped the way that I think. Either way, let's get right to it. Ever heard the joke, anything can run Doom? Well, it's not the only truth about software that's out there. Deep in the weeds, as surely as nature will try to re-evolve the crab, so too will model railroaders try and converse anything that has existed, any piece of software, into their own ability to run trains. It has happened to Minecraft and to Kerbal Space Program, if you can believe it. It has happened everywhere. Who here has heard of Gary's Mod? Any hands? Lots of people have heard of Gary's Mod. Excellent. Have any of you played it? Less hands. Have any of you seen it used to make model trains? Well, you're about to see something new. Gary's Mod is a 3D sandbox that exposes the capabilities of the source game engine for basically anybody to utilize. It was originally a physics-based first-person shooter engine that has basically been pushed towards a virtual interactive environment that you can modify in any way you could really imagine. Combine that with stable multiplayer and tons of in-game building tools, and most of all, a legion of talented hobbyists that are constantly adding to a big pile of knickknacks, doodads, and all sorts of cool tools, and you've got what I would call a party. To the model railroader, specifically, Gary's Mod is a tool to represent railroads just like they would with actual physical models. From the exact power of a motor to the exact position of a bolt, they can represent it all down to the finest detail. Gary's Mod is primarily optimized, let's say, for building city block-sized environments that are for players to explore and mess around with, but the railroaders have modified the game to the point where it can realistically simulate basically entire rail lines down to whatever level of detail they feel. However, it wasn't always this way. We had to fight it first. Now, what in the world do you mean fight? Well, you can't just do what you're hoping to do. Not here. Source is not designed for trains. It is designed for first-person shooters. It doesn't know what a coupler is, or what a track is, or even what a train is. Trains? Do you mean funk_track train from 1998's Half-Life? That is what Source thinks a train is, and it will not cut it for your average railroader. To add insult to injury, there are some very stark limitations we must wrangle. We have a half-mile cube of space to work with. And remember, trains are larger than a half mile. In fact, most railroads are 100 miles or 1,000 miles. We have to get pretty creative with layout planning to make this work. Physics is also very resource intensive. You can only have really a couple hundred solid objects before servers totally implode, and they're only rigid bodies with very unreliable collision holes. Every object is precious, and we have to cut corners. Finally, custom code, so like scripts we can upload and run easily, are limited to 100,000 operations per second. And that might sound like a lot, but consider this. When we execute custom scripts, it is basically the equivalent of running it on a 1960 mainframe. That is the amount of compute that we have per script in this system. It is vanishingly tiny, and it means that lots of things are out of the domain of possibility. Now, wait, I hit the wrong button. The biggest hurdle, beyond any of those aforementioned already serious problems, is the complete lack of knowledge resources. Very few people are using Gary's mod to build model railroads, as evidenced by this room, so you can't just look up how to do things. There are no Stack Overflow articles, there are no forums going over obscure errors, and search engines are useless to you, tutorials are out of date, it's all a mess. Now riddle me this. How do you accomplish anything in this jungle of an environment? You cannot follow the beaten path, because there is none. You have to figure things out for yourself. It takes a mindset shift, for sure. To get things done, you have to pull from distant, seemingly irrelevant sources of potential insight, sharpen your ability to extract information from where you've previously, what you can already interact with, and be prepared to understand nothing until it eventually comes together. To make progress, it's not important what you already know. It's generally helpful to know things, but this cannot help you here specifically. To succeed, you need a method for figuring things out. Some of these problems are new to humanity at large, some of which we'll show you in a moment, and someone in the universe has to not know how this stuff works and take a crack at it anyway for the rest of humanity to be able to know how it does work. Here's a specific example of that in action. I was writing a Python script to arrange Tetris-like modules of a model railroad together in this virtual environment to form a completed world. A map is what they're called. Players submit the modules to me in this block-based form, and it was my job to make them all fit together into that half-mile cube. Sounds like a pretty simple problem, all things considered. I'll just take all the combinations and see what works and write a simple script to kind of automate through that process, and, well, fiddlesticks. Turns out that won't work. Turns out that would be iterating through the number of modules factorial, which, if any of you are familiar with the mathematics, is 1.3 trillion combinations for just 15 modules. It goes up hyper-exponentially for every new module you add, making it completely infeasible for the 20 or 25 modules I wanted to run eventually. So what was I going to do? That was not going to work. The number of combinations and the huge branching tree of possibilities was truly endless. No one had ever made a system for fitting Tetris pieces in together to form a model railroad before. That's kind of a novel problem. No one builds railroads that have to fit into a half-mile cube. This is an absurd problem. It's ridiculous. And you won't be able to find some specialist to help you directly. There's no knowledge resource on this. But there are people working in related fields, people working on similar problems. Maybe we can learn from them. Take it from an abstract perspective. Look at it from 50,000 feet up. Boil it down to the fundamental problems you're actually looking at. It's just an abstract. If you take a system, you have a system of pieces, right? Where each piece influences the future, both in the near term and far, on an 8x8 grid, and some pieces block others, and there's trillions of combinations. Any of you heard something like that before? Any guesses on what I might be referring to? You've got it. It's chess. That sounds a whole awful lot like chess, and that's exactly what it is. Each board state in chess, the tiniest change, has huge ramifications for the rest of the game. You have tons of pieces, tons of positions, and somehow need to find your way to a version of events where you survive till the end. Well, how did the chess people manage it? Well, for exploring outcomes, a big leap was called alpha-beta pruning. I went and did some homework concerning on how computer programs evaluate moves and think ahead in chess, and came back with this optimization that massively sped up the search process. It resulted in an orders of magnitude increase in search power and reduced results from coming in hours to coming in minutes or seconds. It can unearth tiny slivers of possibility through mountains of rubbish, singular needles in trillions of haystacks. Importantly, I did not simply apply alpha-beta pruning directly to my algorithm. It only showed me a computer's ability to improve its ability to see forward in a chess game and win. But I realized that the same ideas, the same concept, could help me solve my module dilemma. If I had to take the lesson that it taught me, not the system itself, about eliminating whole branches of inquiry and how that's really good for making sure that you can find an actual solution, and I had to implement it for myself. And maybe at the end I'll explain what's going on in that image, but either way, the important part was not to immediately jump to, oh, this is chess, that makes it all simple. That's not what's going on. I had to start thinking about code in terms of the widest possible context. One would not navigate around a mountain range by trying to find tiny tunnels that lead directly through the mountain. That's ridiculous. No one would ever try that unless you're a caver, and maybe even then, not really. You'd go around the mountain. That's what you do. A lot of the time, working on problems like this does not give you a straight borehole answer through the problem to get to the solution. You end up taking a circuitous route. It won't take you there directly, but you will learn things on the way when you get higher up the mountain. You'll start to see things. You might try something and it kind of works, and then you realize you've stumbled into an entirely different part of the mountain that you never saw before, maybe even a new problem you're hoping to target. That exact situation actually happened to me while working in Gary's Mod. It was a mountain that I did not realize was a mountain until I was too close to it to recognize what it was. One of my most popular scripts in Gary's Mod that people use on a regular basis is a system for creating prefabricated randomized freight trains. Basically, you give it a command and it creates a train. The cars are relatively simple, but the system is easy to use and saves users a lot of time. Without it, people have to build and manage and deploy their own fleets by hand and manually re-rail every single car every time they want to run any kind of train. And for hundreds of cars, even if you're doing it in 30 seconds, that's a lot of time. Either way, hours of work and maintenance are replaced with a short command, and it's as a result, it's considered one of the essential tools for anybody doing railroading in Gary's Mod to be able to use this, and it's probably in use by someone somewhere 24 hours a day. The system has a notable limitation. It only understands fairly shallow building practices, using existing models and simple construction and kind of a basic template where all cars are pretty well the same. Most people didn't care, but there would be cases where I wished it could create higher quality freight trains, and the architecture I had built was simply not complex enough to handle what users wanted. What I didn't know is that this line of reasoning was about to take me for a wild ride. One day, I started experimenting with a much more generalized framework that was orders of magnitude more complicated than what I had been using initially. However, in return for this complexity, it promised to remove all limitations on what I could do. The sky was the limit. It was a complete rewrite, in effect. The more I worked, the more excited I got about it because everything seemed to be falling into place. I came to the object-oriented approach that most programs used and made a version that could fit on this limited system, and I don't know, theoretically it could work, and in my test environments, like that image, it's creating very nicely detailed custom freight cars. Like, I built those myself and then imported into it. No one's ever done that in Gary's Mod. There was never a system that could automatically assemble something as complicated as that. Scope was expanding, but I was solving the challenges as they were coming. If there was a problem, I just added more code to work around the issue and kept right on trucking. After 4 months of feverish development, in which I had somewhat of the time of my life, I had produced a working prototype in that test environment, and it came time to deploy the script on a live server for the first time. I was excitedly connected to a virtual environment, deployed the system, and everything froze. Turns out, even the simple activation of this script had taken so much of the server's resources that it simply gave up and crashed the server. The script was too big, too complicated. It wasn't a bug I could solve. It was an engine limitation hiding in plain sight that I had failed to work around. I had been testing the system throughout its development, but only in my little virtual world where I had the environment fairly well all to myself. In this more realistic scenario where the script was competing with other players and other scripts for server processing resources, it suddenly didn't have nearly what it needed to get it off the ground and brought everything to a standstill, which is kind of impressive considering that these scripts have bottlenecks in them to prevent them from using that much server resources, and it blew right past that limit and crashed the server before the server even knew what hit it. It was kind of a big deal. Suddenly, my rush of progress, my exhilarating experience, came to a sickening, grinding halt. What in the world do I do now? I can't meaningfully cut features. It's the core architecture that it doesn't like, that object-oriented system. After another week's of brainstorming and testing a few last-ditch solutions, I was forced to throw in the towel. The system wasn't inefficient per se. It was fairly well coded for what it could do. It could do too much. It was too big of a system, too capable. I had designed the wrong tool for this situation. In the end, I essentially had to roll back all the way to before the rewrite. It felt like a huge loss to throw away all that code that I had just spent several weeks tinkering with and very much enjoying, but I remember that raw text is not the thing that I ultimately got out of this experience. I learned a lot of things about the limits of what the code could do in that environment. I still use some of the architecture tricks I learned while trying to remedy it. It was the first time, also, that I could remember getting seriously burned by a narrow mindset, a lesson that I never forgot. I thought I could just keep writing code and all the problems would go away eventually, but I realized that structures and the scope of what you're actually trying to achieve are often bigger obstacles than any particular piece of software would ever be. It forced me to stop thinking about my code as code and functions and libraries and merely text, but to start thinking about what the user actually wants out of my system. What can I reasonably provide? What's actually even feasible here? What's something that would cut it instead of something that's going total overkill and trying to solve every problem? The experience wasn't so much of a waste as it seemed in the end. I came back a few years later to a similar concept based on the existing architecture instead of a new rewrite, and some workarounds that would be less flexible, but they would accomplish the headline features that a lot of the original was hoping to go for. It only took about a month to make, as opposed to 4, and was widely celebrated by the people who used it as a fairly massive improvement. There were still hurdles to overcome and things to learn and stuff to do, but I was more prepared this time because I had jumped in that first time and learned everything that I could, took the bull by the horns and tried to figure everything out. It showed me the wisdom of, after doing that, scaling back and trying to figure out what the 20% that matters is, as opposed to the 80% that can only really, in retrospect, be a teacher to what you could do better. The first attempt was tons more work and tons complex and more waste, but it taught me something, and that means that it ultimately wasn't a waste that I did it that way. It just ended up being a different path to the same thing. When embroiled in these large projects, you end up figuring out more than how to deliver the best product. The real benefit to plunging into the unknown like this is just how much you can improve your own knowledge of a subject and your own ability to prosecute things in it. I've learned so many random subjects just because I took the time to, go into it, basically. And then at some point in the future, I bumped into that problem again. I was like, I've got a tool for that. I've seen that before. It's not drag and drop. It merely gives me an idea. It expands my tool belt in ways that I could not predict how it would be useful to me. For example, on the same car creation system, there's another challenge you must face. You want to give the player a string of cars, but where do you place them in the world? Like, genuinely, how do you actually know where the rails are? You would say on the rails, obviously, but the engine doesn't know where the rail is. It's a first-person shooter engine. It has no concept of track. It's just a big collision mesh as far as the engine's concerned, and you can't even access that collision mesh directly. You can't say, what is this vertex? It doesn't know what a vertex is. It's all baked geometry. So you have to go at it with in-game tools. You have to go at it with, like, can I see this? Can I go to this? Can I bump into that? There's no such thing as aligning to rails in Gary's mod because Gary's mod never had that in mind. How do you follow rails then with this limited capability, though? I could relentlessly probe every nook and cranny with vectors, or try and make a 3D visualizer, or hunt for parallel lines in the environment, or do something where it predicts curves ahead of time using stuff. I don't know. I tried a bunch of random things, and none of them worked. The only thing that I could reliably trust to follow the rails is a train. Wait, so why don't I just do that? Why not just make a train that tells me where the rails are? I made an invisible set of wheels that goes ahead of the system and scouts the rails, sniffing ahead and seeing what's ahead, and then laying a line of nodes behind it that represents the track positions so that it can be fed back to the machinery. Couple that with a fast method to find exactly the right nodes and how far away they are so you get all your spacing right, and a lot of random math and functions to figure out how to get it to adapt to hills and place things on slopes and curves and whatnot. And, eventually the system could follow the rails on its own. It might not seem particularly impressive, and that's because it's not, but keep in mind this system has no idea what track is. There's no library for continuous curved lines either. There's no object system for representing freight cars as an abstract before they're initiated. It's all just code and math and logic and numbers. It's not some wizardry either. It just took a lot of figuring out, and as a result, it taught me a lot of different systems and how they might be useful. I've been able to leverage things I learned working on that system later. It taught me how to use Bezier curves, despite the fact that I ended up not using them. It turned out that I could just decrease the sampling rate, and it was basically better with linear interpolation. But, those Bezier curves have been useful on future things, and now I know how they work. I will be showing you one of those projects later. Solving the problem the hard way by myself made it easier to solve future problems and made me a better programmer because I'd seen more things in action and I had more of those ideas to pull from and say, well, it might be this. I stayed in the trenches, took the time to learn, and ended up coming out ahead because of it. Well, there's some things you can't be ahead of. What about the big problems? Up to this point, I've shown you something, basically a simple pattern. I find a problem, fiddle with it, figure out how the system works, and then implement a solution using some clever trick from the internal side of things. But there's a few instances where you need more than just fiddling with things to make it work. How do you solve big problems where, no one has any idea? Some problems are so large that there's no hope of simply salvaging the existing situation from inside. You have to go outside. You have to make a systematic breakthrough. The final problem I'll be talking about is in Gary's mod, one of the biggest bottlenecks is the environments. the maps. People have perfected the process of building the trains, and they can make any train you can imagine down to an immaculate level of detail, but the environments, the rails, the places we actually ran the trains lagged far behind. They were low detail, infrequently produced, and took literal years, and I do mean years, to finish. In the entire 20-year history of the game being used for model railroading, only a handful of good environments have ever been made. Probably only about 10 or so, and we're only probably using 3 or 4 of those in the modern day. It's a problem. The choke point is the sheer amount of effort required. You have to place every bush, every facet of every building, every tree, every pile of dirt, everything, manually, one piece at a time. I attempted to solve this problem with the modular project, that Tetris thing that I talked about earlier. What if I amortize all this work across multiple people and get it done? But only the best builders among us could only manage to construct a mile or 2 of railroad at a time, and we would need 10 or 15 to make a good, reasonable-sized map. Even the modular map, which was a step forward, was only 7 miles long, overall scale, and it took 2 years to make, and a tremendous amount of wrestling of the engine with problems we never thought ahead about. It was like, oh, wait a second, everyone's made their environments too detailed for the game to handle. God darn it. It was a step forward, more of a step sideways, and it was not going to fix the problem. The demand was sky high, and the production could not keep up. Well, what are we going to do? Fact is, we were constrained by the Source Engine's very old environment editor, a program essentially unchanged since the 1990s. It was tailored to constructing spaces on the scale of tens of feet, not tens of miles like we were trying to do. And for reference, a mile is 5,000 plus feet. That's a lot of feet. It is quite literally building cities one corner of a city curb at a time. It is a loathsome, slow process. Small fixes were not going to improve this. Our entire process was flawed, and we needed a whole new way of doing things. And yes, the Hammer editor is a nightmare. It has problems. So I asked a different question. Why are we building these maps by hand at all? Most train games import satellite imagery from Google Earth, or have very small environments deliberately that were built by hand. Most players don't particularly care about this, but for me it's a problem. These source maps are just files at the end of the day, which quite literally it's just a JSON file if you crack it open and take a look at it. Then why can't we make maps with code instead of with an editor? If we could understand the structure, we would no longer be constrained by the foibles of the Hammer editor. I could generate the map directly, and with lightning speed, no longer constrained by my human ability to work. So that's what I did. I started building a system that could take the core concepts of model railroading, expressed in math and functions and other things, and build it at scale. Track routing, terrain shaping, object placement, all the things you might want, and take all that data and assemble it into this VMF format itself. It took some doing. I had to figure out how Perlin noise works and how to apply Perlin noise to an engine that sees the ground as basically flat sheets of paper with triangles on them. But you have to reverse engineer VMF and figure out how to place the track pieces. It took some work, but we got somewhere with it. If I remember the situation fairly clearly. The entire project was written on the back of a digital napkin in my notes folder on December 2nd, 2024. And on New Year's Eve, 2024, less than a month later, I had produced and uploaded an entire finished map. I'd spent barely enough time to get it working, just enough to figure things out and get it done, and the results were absolutely staggering. It wasn't long, it wasn't impressive, it was low detail and barely 2 miles overall, but I had gone from a blank file to a finished product in 3 days, which was with the previous time in the month, the previous 27 days, simply spent writing the code to make that generator work. The second to last day was assembling the track by hand, since I decided to do it that way instead of doing it with code. And the final day was simply wrestling the map compiler to actually accept the file and get it to work out. And the result was an obscenely fast turnaround. This is 2 years versus 30 days. In terms of in return on investment, it was sky high. The 30 days of hobbyist time had produced 2 years of railroad, a literal 25 times increase, a 2,433% speed increase. And the best of all, I could regenerate the whole thing again. I could push a button, and 10 minutes later, code will have done the work once more. This map is still in rotation for people. That map that I produced there, people still use it. So it was a proof of concept that worked. I got it to the point where I could figure things out, and people accepted it. It was a system that could do it. What took a decade to build manually, I could write in code in 15 minutes. It's bananas. We're no longer talking about optimization in the standard sense. This is a systematic rethink of what's possible in Gary's mod and pushing the boundaries thereof. No one has ever tried anything like this in Gary's Mod, so far as I know. There was one VMF library on GitHub that I found that was tremendously incomplete, and that's it. This is frontier territory. It will allow us to perform projects that in Gary's Mod were previously completely infeasible. I actually took a commission on a map shortly afterward for a decent amount of money, and it's the first commissioned map that's ever been made. It was a new door because no one would feasibly say, I'm going to dedicate the next 10 years of my hobby time to building your map. No one would ever pay for that. But with this, now it's possible. The project is in beta right now, and it'll probably be on its way to completion by the end of the year. It's going to be a 20-mile environment, which is, only 2 other maps have ever been made that long, and the development will only have been around 2 years. It's way faster than anything else. Despite the scale, it's also probably going to be the most realistic map that's ever been made, because I get to focus my time not on placing individual trees, but on actually researching the railroad and figuring out how to implement it, and then from there, Most importantly, this was not accomplished because I am the best mapper or the best programmer. It's because I had a random idea to shove 2 things together and see what happened. That's the genesis. Quite literally, this massive breakthrough happened because I noticed a chance possibility. I'm like, but this is just a file, isn't it? That was it. That was the only idea that made it possible. Recognizing opportunities like that, that's what I'm hoping to give you all. Is like that's a tool. It's a tool you can use. I don't want to just introduce you to a bunch of systems of like, oh, here's Bezier curves, here's this, here's that. I want you to give you a system for finding systems, something that allows you to look out into the possibility space and see things like that total overhaul just lurking in the shadows. Whenever I'm faced with a problem to solve like this and want to learn something from it, here's the framework that I follow. First off, I have to orient myself, figure out what I'm even looking at. What system really is this, really? What's the main process, the through line? What does it remind me of? What is it potentially similar to? It helps you synthesize not the specifics of a problem, but the generalities. It could give you potentially a hint to be like, oh, but this is an area where that field made more sense. This is an area where that something works better than this. Maybe I can work from there. Then when I zoomed out and thought of my module project as a linear move-by-move game instead of something else, many things were clarified. Secondly, you must probe things. Find a potential avenue. Figure out what might give you an edge. If I rebuild this part B to output A instead of C, what changes down the line? How does this actually work? You're not following a fix-it tutorial with the system. You're not following instructions. You're having a dialogue with the system. You're asking it how it behaves, and it's answering you, and you have to keep asking, and it'll keep telling you. Try a few different ideas on for size, like what might work, what might not. Explore your surroundings. You have to. I thought and fiddled about with 4 or 5 different track follower mechanisms before I landed on that one that I went there, and each one was like, oh, that won't work and this won't work, but I learned, and eventually I found one that did work. In the same way, brute forcing my module placements didn't work, but maybe I can make it smarter instead. Thirdly, you must construct a model in your mind of how this all works. If I do X, Y happens. What happens when I induce Z? What does it change? What are my boundaries? Can the system accomplish the goal I'm actually looking to do? Will this all come together? You can waste a mountain of time if you skip this step. I've spent weeks engineering a specific function or architecture to only realize it can't do what I need it to do. It won't work. It's either poorly suited to the situation it's in. I have to think about that ahead of time. I have to model what I'm actually doing. Finally, you just have to build it and find out at some point. Don't go overboard. Just construct what you need. You don't need to do more than that. You have to make the process details complete, but it's a situation you can mishandle. What I did during my rewrite blunder, I just assumed things would work out if I just kept adding code and not testing it. I just assumed things process would keep working out. But as long as you can go back and say, no, this actually does work. That quick prototype I wrote was for the map generator was not the final version of that program by any stretch of the imagination. I went back and rewrote the whole thing afterwards. But the proof of concept was more than enough to intrigue me in the idea. Once you see it running for yourself to prove the concept, then you can go and build the whole deal, and then you'll get more out of it. Chances are, no matter what problem you're solving, things will not go exactly according to plan. But these are just steps that could help you build an intuition on what might go wrong and also learn more out of what you're actually doing. Keep testing what you know. Keep working forward from there. Keep experimenting, basically, and potentially you'll learn something. Even after I had to scrap a bunch of that code, the things I learned there offered me other solutions, even within the same project, to go out and try later. You can always go back and reorient the problem. Probe for more ideas, rebuild your mental models, and build more prototypes and see what you've learned. As long as you give yourself the space to be creative and to tinker, you should eventually arrive at a solution of some kind, or you might find yourself somewhere that you never recognized. Like, I somehow found myself here, even though the previous genesis of this was just tinkering, building seminars in my own time for other railroaders like myself. I find that I get better results when I write down the outcomes of my tests and look at them later. It's a fairly well-known psychological thing. Suddenly the passage of time will put me in a better space to understand what's actually going on, and then things that were previously invisible to me will jump out. Like, I didn't recognize it was like that. I have a whole... The only other requirement is you have some fun doing it. I have a whole folder of things on my computer that are just development bugs that I found, like that same node system spiraling through the sky after the system forgot to remember how to stay on the rails and made a literal tornado of freight cars stretching off into the horizon. That was fun. Things like that. As long as you're keeping going on it, and it might not be obvious from this jumble of collection experiences, but it all hammered home, to me at least, a fairly specific lesson. For each of these challenges, I did not know what the path to victory would look like before I got there. I did not anticipate the traps. I did not route around the confusion. I did not dodge the obstacles. I just had to learn from them. The more I could learn, the faster I could move, however. The more I understood, the more I could apply later, and the more I could get done. In short, I didn't need to know particularly what I was doing. I needed to know how to learn. If you prepare yourself for a specific task in the future, no doubt you will do very well at it, but what happens when things go completely sideways? What happens when who do you turn to? What process can you do when you're off the rails or no one to turn to? How can you possibly prepare for that? I humbly offer you one solution. Ready yourself to learn about the structure and the function and just how it works of whatever you encounter, and then apply what you've learned there and previously to new problems in new combinations that people haven't seen before. With that tool in your belt, that way of thinking on mind, every new challenge becomes an opportunity to gather more insight about everything. Every system you learn, every mechanism you understand, becomes a pattern you've seen before, a tool that could potentially help you tomorrow to conquer something else. The intricacies of chess might help you solve a pathfinding problem. The structure of code might give you intuition on how to do some accounting. You can bring the full force of insight from far off places, ridiculous places, to bear where no one would expect. And that means you have an edge that allows you to make progress where no one has gone before. That's how to solve problems where no one has gone before. Any questions or comments?
All right, first off, give him a huge round of applause. That was awesome. All right, if you've got a question, I will bring the mic over to you.
First of all, I really agree with and appreciate the message. I think it's great to learn. I think that's very useful in problem solving in code. Do you use LLMs to as a learning resource? Like, do you have a chatbot that you're like, I want to know more about this, and you don't necessarily know somebody, so you consult something that you can converse with?
Yeah, that's a section that got cut from this talk, but it's a fascinating thing. Because there's no learning data on the custom languages or the specific interactions in these games, chatbots just stink at solving problems in Gary's mod specifically. But on the flip side, when you bring it back out into that generalized learning environment, we're like, oh, that's kind of similar to this. You can I haven't found a chatbot that's that great at doing the intuition work just yet. They can offer suggestions, and your brain might jump from there, and I do use them for that. But in terms of actually doing the work, I don't think they can cut it just yet. I mean, I workshopped this whole talk with ChatGPT, and you ask it, now what's wrong with this talk, and it'll give you answers. It's a useful way of doing things, but it can't take you all the way.
Hi, Thomas here, longtime listener, first-time caller. So first of all, I want to congratulate you on having a full head of hair, because if I had to solve the problems you were solving, I would have ripped out every single one on my scalp. The question I'm wanting to ask here is, in this learning and problem-solving process, have you ran into places where the frustration was just too much to handle? And how did you handle that?
An excellent question. I know that the frustration of not knowing what you're doing is big, and it drives off the vast majority of people from doing stuff like this. Like, the part of the reason that the script that I wrote did so well is because it automates away a process that other people would have to do. In terms of how do I solve that for myself? Oh, man. There have been so many incidents of banging my head against a wall for a particular problem. There's like, but I can't, why isn't it not working? Why? And of course, that makes you want to pull your hair. I guess, to be honest, it's a benefit of being a hobbyist. It's not going to kill you at the end of the day. You don't have to make it existential. You can say, this is just a problem that I can think about later. And if you do get yourself just mentally far enough away where it's not up in your face anymore, where it's no longer the mountain directly under your feet, but it's kind of the distance, then suddenly you can see it for the mountain it is, something you can traverse instead of something that has to bury you. So, not much of a solution for people who are in the thick of it, but, well, if you're in uncharted territory, I suppose I wouldn't expect people to be able to know how to go in the first place, because some explorers go off the edge of cliffs. You know, it's just what happens to them. And if you have any resources to leverage, by golly, do it. Because
So FaceBunch recently announced S-Box. It's for Source 2.
Oh.
Do you plan to make anything using it?
Fantastic question. All Gary's Mod train builders are waiting with bated breath to see what the open beta looks like, or whatever it is that they're planning over there. And there's so many potential things, like, for instance, the half-mile cube, gone. Source 2 can theoretically handle like 14 miles. It's going to be fantastic. There's a problem with that, and another section that got cut from this talk. One of the reasons we're still using this dinosaur of an engine is that it has an advantage buried in all of those disadvantages. Sure, it limits you at every turn. It throttles everything you could possibly do, but all that throttling means it can run on old hardware, it's easy to understand, and it means that new people can get into it and start doing things quickly. That Hammer editor, I just dunked on Hammer a huge amount, and everybody hates Hammer for the things it can't do. But the thing it can do is be way more accessible than Unity ever was. It's already installed on your computer with any source game that exists. You can boot it up and immediately see how to do things. It's simple, compressed, functional. It teaches people just by using it, and in that way, it's way better than all these big, complicated learning environments. It's why people still use it. So for Source 2, it's all going to hinge on that. How easy is it to develop for? Is it like Unity's pipeline? Is it like Unreal's pipeline? We all hope it's not like Unreal, because no one will use it. You know, it's that's the deal. So we have to wait and see.
Any other questions?
I'd be happy to elaborate on the nuts and bolts of any system. Actually, I should go back to that slide, shouldn't I?
We got a couple right here.
Yes.
Pretty simple one is, do you use other sources for your models and stuff? Like, have you gone to, I don't know, the model video game train railroad tycoons and stuff to get models, or do the people that mod in Gary's Mod do the 3D modeling themselves and measure the trains, and like, how do you build your models, the 3D models specifically?
That's an excellent question. It's an eclectic mix. So that model up there in the top corner, that is imported from Microsoft Train Simulator. It's technically abandonware that's open source, so people just took it and done it. That's another tremendous advantage of Gary's Mod. You can rip anything from anywhere and it just works. Like, can Source 2 do that? Probably, but you know. Other models, like that one in the very beginning and some of those other models, you're not going to believe this, but that screenshot of that white freight car up there, that's also Hammer. Some insaniac decided to take the Hammer editor and take out the compiler component and put in a model compiler instead, where it takes the brush geometry of the world and turns it into a model. It's called Proper. It was originally designed for making fast exporting buildings. And someone said, you know what, I could make trains with that. So now we have to wrestle the worst of both worlds, dealing with vertex loss, imprecision, other nonsense, and terrible texturing, whatever else. But we can make trains in it. I know how to make trains in it. I'm probably one of the last humans on the planet that still makes trains in Hammer. But yeah. So a variety of sources. Most people use Blender. It's probably the best answer. Yeah. But like, people use Autodesk. I've seen some other people use other even stranger things. It's uncommon, but yeah.
Okay, you said you wanted to get into the nuts and bolts of it. I'm ready to throw down.
Sure. Let's throw down indeed. All right.
Yeah, so actually, that one slide, yeah, right there. So I'm actually really curious on how you managed to do the actual generation of this, because on one of your last slides, it almost looked like you had trains going at different, or train tracks going at various level heights within the map.
Yes.
Which
Smart
implies
cookie.
you get more surface area for more track to cover your
Yes.
mileage. I'm wondering, how did you go about generating that? Because my assumption is I would probably do something like wave function collapse or something like that to procedurally generate this stuff. But that comes with a lot of rules that are involved with it. And unlike the chess algorithm example, where I believe you said you use that for the specific pathfinding, right? That seems like a totally different problem than the actual generation of the tracks itself. So how did you, what algorithms did you use, and how did you make it so that it can actually work on a vertical, horizontal, 3D axis, essentially?
That's a good question. Essentially, what you're looking at here is screenshots from a quick and dirty Python program that just represents everything in terms of numbers and turtles. The objects in question, I didn't get to make a good screenshot of one. That's the best you're going to get. That middle thing down there is actually the object itself in Hammer, the whole thing. And I've constrained it to a sort of block-based thing where I can just represent it as a grid that says occupied or not occupied. That was the original version that could only do 2 dimensions, and then I upgraded it to a version that thinks in terms of heights. So eventually it'll just fill in those things, and it can basically feel around. Hey, is there a block here? Is there a block here? And at that point, it literally just guesses and checks its way through and says, hey, can I make this work? The innovation that with alpha beta pruning here was not necessarily it's almost a lie to call it alpha beta pruning, because that looks into the future and says, should I cut this branch? I just wanted to reduce search space, and I reduced search space by constraining which modules it would pick after certain others. And I originally wanted to make the solver super fast so that it would keep going through all these things and looking as fast as possible, but it would just waste its time looking through huge amounts of, actually, and this isn't a bad situation. We already see that this path that it's creating, you can kind of see it's going forward in time, adding more modules to the end and kind of exploring. That's already going to implode and die, because it's already just about cut off its own space in the middle. And if you've ever played Snake, you know that's a terrible idea. So it has to be able to get out of that rut quickly. And the way that I made it do that is to basically be more constrained about what it can actually put next to each other. It'll always start with a certain module first, and then it makes sure that certain...
Okay, so, I mean, did you use wave function, or did you use a different heuristic algorithm?
There is no heuristic. It just looks. And I started pruning the overall space by saying, this module here, this yard, has to be 2 modules away from other types. And this next module can only be of this type, which means instead of looking through 15, it's looking through 3 or 2 or 1. And instead of looking through 15 factorial, I can make it 13 factorial, because certain modules always have to be the ends. So I just keep pruning off things like that. It's simple stuff, but you had to think of it to do it. Maybe that doesn't answer your question. It's not, there's a billion ways. And like, some of your ideas can be duds. I mentioned Snake, similar to Snake, but using Snake as an analogy for that is bad, because you're dealing with pre-built pieces instead of being able to change your direction willy-nilly. So, yes.
Hey, so I had a question that was already answered, sort of like, why did you choose Source over, I'm trying to think of the other engine now, thinking about
Unity?
it. Unreal, or something like that, yeah.
Oh, yeah.
And so that was already answered, but another question that like sort of developed from that, and he mentioned something about hair. I was less worried about the hair on top. Your mustache looks great. I was just wondering, how do you take care of it? That just was like barely in the back of my head. I was just like, I gotta ask.
Well, I apologize if this thing's been distracting people this whole time. Golly.
Back of the head.
Man. I have no procedure. I literally, in the same way that I'm figuring things out just with this code, I am figuring out the hair in front of my face out. I think I just got lucky, because my brother can develop no facial hair at all, and I say that I stole it all from him.
Isaiah, enjoyed your talk. Have you thought about any practical applications for this?
It's a good question. You're like, oh, but this is all just hobbyist work. Why should this be influencing the big world of business? And that was a fear of mine of like, oh, maybe this isn't going to amount to much. But, well, I did sell somebody the ability to use my software, and I'm going to sell more people the ability to use my software. And I'm hoping, eventually in my life somewhere, that this amount of experiences I've gathered traipsing my way through various things will put me in a position where I can solve a problem that's important to the world that no one has even possibly considered. And I have data to back this up, because every major inventor in the past history of forever has been in the same position. Wozniak and Jobs got where they were because one of them was a hardware programmer and the other was a software guy, and they got together and said, but there's these components. Why don't we make a computer out of that? That's literally, that's the whole thing boiled down to an idea. It's just because two people were good at their jobs and decided to mess around a little bit. Quite literally, it was messing around until it was no longer messing around. So I'm intending to mess around my way into finding something that's worthwhile, or maybe not. I don't have a tremendous idea of where my future is headed, but just like this talk would teach, I hope to not hold it too strongly because I might go the wrong way. Yes.
This is less of a question, more of just a comment. You said you weren't sure how this would apply to the world of business. The company I work at has COBOL, Java code that calls COBOL code, and so we've got similar old outdated technology doing new things, building things on top of the old constraint. It's absolutely applicable to the real world. just wanted you to know.
Fair enough. Isn't it fun? You're like, but this can't do this. I learned my programming experience in that tiny dead-end mainframe language. It was the first language I ever picked up, and it was introduced to me because it was useful in that environment. Tons of people get introduced to programming like that, but it was a terrible language. It's an objectively bad language. Still, Python felt like superpowers. Yes.
So first off, with that thinking model, orient, probe, build, verify, or test? Oh, orient, probe, model, build. With that, presented with enough real-world problems, you'll definitely solve something with that.
Yeah.
So if you could only pick one, and you can, considering the wildly amazing presentation that I wasn't expecting at all on the topic, I mean, that was mind-blowing. That was great. And how serious railroad hobbyists are. Which one do you prefer? The process that you just described here that you can apply to a lot of other things, or the end result that you get to enjoy in your hobby?
You can't stick me here.
You only get to pick one.
No. I'll take systems every time.
Okay.
I am the guy who loves systems to death. And that's why I can take the same systems thinking and be like, I'll use this to solve trains. I'll use this to fix my lawnmower. I'll use it to do whatever. It's a general tool. And I didn't end up getting into this, but it's something, it teaches you how to solve all kinds of problems. You can abstract all manner of things using this. It doesn't just have to be code. That was a section that also got cut. It's a general way of looking at the world. What can I probe? What can I change? How can I think about this in a way that I potentially understand better? I was just telling somebody about an analogy where I had to learn how to drive an unsynchronized manual at work. Big, unwieldy transmissions for big, unwieldy trucks. And it's not like a synchronized where you can just hold it down until it eventually sinks. You have to hit it in just the right spot. And I was like, it's kind of like those movies where some bowman, some Hawkeye draws a bow and tries to stick it through a bunch of rotating targets and hit the exact thing. That's exactly what hitting gears on an unsynchronized manual is like. So why don't I think of it like that? And it helped me do it. I was like, that makes sense. I can apply it like this. It's not a code problem at all. I just used a movie to solve a truck transmission. What in the world's going on here? If I had to pick one, systems. Most people would not agree with me. Most people would say, but I love trains so dearly. I just like seeing things in motion. I like freight yards. I like logistics. Yeah. Excellent question, though, because most people would be truly stuck by that one.
So I'm looking at your cycle here. Can you talk about the connection between building into orienting? How does the end of the cycle beget the beginning of the cycle again?
Excellent question. This is one that I had to think about a bit because the idea of it being circular was actually ChatGPT's idea, so I'm going to blame that. But it was very I argued with it. I was like, why do you think this should be a loop? It boils down to this: that at some point, this is not a linear process. You're going to have to zoom back out, having built something, and say, okay, now it's behaving like this. Can I take this thing that I just built and reorient it perhaps into a larger structure? Can I think about this differently again? Can I say, now that I've got this part working, what about this? You might think of it as different abstraction layers where they're not necessarily connected, and you might have to rethink your abstractions upon having completed something. Now that I have something that just spits out train map, I get to think about that differently, no longer in terms of what it is, but in terms of what it can do, if that answers your question. So that's how it goes back around to Orient. loving these questions, by the way. Levi was like, oh, you're going to get to ask him questions. Oh, I do love answering them.
Yeah, normally Isaiah's always asking really good questions at our presentations, so you guys didn't disappoint.
Yeah, I'm so glad to have all the questions. It's quite fun.
Any others? Going once, twice. Please give him a huge round of applause. That was amazing.